Next point is standing waves, which are produced by two identical waves superimposing while traveling in opposite direction. That's why we discuss the reflection, because reflections give the identical waves which are moving in the opposite direction. If they get reflected from the rigid end or the fixed end, then there is a phase difference of pi. And if they reflected from the open end or the free end, there is no phase difference. To drive the standing wave, suppose incident wave is given by y1 xt. It is equal to a sine kx minus omega t. This is the wave which has amplitude a and moving in plus x direction. And if this wave get reflected from the open end, so it will move in negative x direction with no phase change. It get reflected from free end or the open end. In that case, we can write the reflected wave as y2 xt equal to a sine, and because now it is moving in minus x direction, so it is kx plus omega t. This is the equation number 1, this is the equation number 2. Now these two waves meets and superimposes, resulting in the standing wave, and by principle of superposition, we can write yxt, this is the resultant wave, that is equal to y1 xt. This is the algebraic sum of the two waves y1 and y2. Substituting the value here, this will be a sine kx minus omega t plus a sine kx plus omega t. Here a is common, so it is taken out. So we can write sine kx minus omega t plus sine kx plus omega t. Now we will use the trigonometrical relation, that is sine c plus sine d is equal to 2 sine c plus d by 2 cos c minus d by 2. Here we consider this kx plus omega t as c and kx minus omega t as d. So on solving, we will have a into 2 sine c plus d by 2, that is kx plus omega t plus kx minus omega t by 2, and cos c minus d, that is kx plus omega t minus and kx minus omega t divided by 2. Simplifying it, this omega t get cancelled, and 2kx by 2, this will give kx. So we can write it is 2 sine kx into cos. Opening this bracket, this will be minus kx plus omega t, so kx get cancelled, and 2 omega t by 2, that means it is omega t. So finally we can write that is xt is equal to 2a sine kx. This term is the amplitude of the resultant wave, which is a standing wave, and it is cos omega t. This equation is the equation of standing wave. This is the wave which do not travel but its magnitude or amplitude changes with position and time. So amplitude of the standing wave is given by a, that is equal to 2a sine kx. Here a is the amplitude of the traveling wave, which interferes. K is the propagation constant written as 2 pi by lambda. From this formula, we can find the maximum amplitude and minimum amplitude. So A max will be 2A when sin kx is equal to 1. For this, kx should equal to n plus half pi, where n is equal to 0, 1, 2 and so on. So we can write it is, because k equal to 2 pi by lambda, we can write 2 pi by lambda into x equal to n plus half into pi. This pi and pi get cancelled. We can write x equal to n plus half into lambda by 2, where n is equal to 0, 1, 2 and so on. These points of the maximum amplitude are known as antinodes, and the distance between two successive antinodes will be equal to, if we see the equation, if we first put n equal to 0, then it is lambda by 4, and if we put n equal to 1, it will be 3 lambda by 4, and if we differentiate, we will get the distance is lambda by 2. Similarly, we can calculate the minimum amplitude using the expression of the amplitude A, that is equal to 2 sin kx. A minimum will be equal to 0. This implies that sin kx will be equal to 0, and sin kx equal to 0 refers the sign n pi, where n is equal to 0, 1, 2 and so on. This implies that kx should equal to n pi, and because k is the propagation constant equal to 2 pi by lambda, so we substitute here 2 pi by lambda into x equal to n pi, and this pi and pi get cancelled. So this implies that x equal to n into lambda by 2, where n equal to 0, 1, 2 and so on. So these gives the points of minimum amplitude, and these are called nodes. And distance between two successive nodes like antinodes is equal to lambda by 2. We can check here. If we put n equal to 1, it will be x1 is equal to lambda by 2. If we put n equal to 2, x2 will be equal to 2 into lambda by 2. So distance between them is x2 minus x1, 2 into lambda by 2 minus lambda by 2. So it is equal to lambda by 2. So distance between the two successive nodes or the two successive antinodes will be lambda by 2. To draw the graph of the standing wave, we take a simple case of the string which is fixed at two ends. So these two ends are the fixed end, and here nodes exist because displacement is 0. And simplest case has one loop, that is there is an antinode in between where displacement is maximum. The equation of the standing wave is 2a sin kx into cos omega t. This 2a sin kx is the amplitude of standing wave, and cos omega t results into the variation in displacement at a particular time. So we have already discussed that amplitude minimum is 0 at x equal to n into lambda by 2, and a max equal to 2a at x equal to n plus half into lambda by 2, where n is equal to 0, 1, 2 and so on. So minimum amplitude is resulting at the nodes here y equal to 0, and antinode we have the y equal to 2a. Now taking the cos omega t into consideration, the resultant displacement will also change, because this cos omega t, which has the magnitude, maximum magnitude is 1 and minimum magnitude is 0. So at node, we already have the amplitude which is minimum and it is equal to 0. And if we also include the factor cos omega t, there will be no change because 0 multiplied by cos omega t will also give 0. So at node, the amplitude will always remain 0. But if we consider the antinode, which has a max equal to 2a, and now we also consider the factor cos omega t, and this omega t has the magnitude from 0 to 1. Therefore, the maximum amplitude at the antinode changes from 2a into 0 barabar 0 to 2a into 1 equal to 2a. That means if we make a change because of this cos omega t, after some time the oscillation shows by this red line, and after some time it further reduces, and ultimately there will be a time when this becomes flat. That means net amplitude becomes 0, and after that again it starts to increase and becomes maximum. That means we can say standing wave does not travel, but it fluctuate or oscillate at their positions from 0 to 2a. Next we will discuss the stationary wave in a stretch string fixed at the two ends.